Hello, we're starting Unit 7, Section 2, Graphs of Radical Functions. So here we have a square root, because that's the default. So we're going to make a table, and then we're going to substitute the x values right there for x. So square root of 0 is 0, square root of 1 is 1, square root of 4 is 2, square root of 9 is 3. Right there. So, and then you plot those points. That's what I did there. So now the cube root. So cube root of 0 is 0. Cube root of 1 is 1. So that's why we have 0, 0, 1, 1. And then I go with negative 1. So cube root of negative 1 is also negative 1. So negative 1 right there. And then let's just do two more. So 8, cube root of 8 is 2. Over there approaching 2. And then negative 8. So cube root of negative 8 is negative 2. So these are the two parent functions for the square root and the cube root. And then we need to determine domain, range, and the intercepts. So it's really not too bad after we have the graph to determine that. So the domain is everything including 0, from 0 over to positive infinity, both for domain and range, because it starts right there on the x and it goes up right there on the y. Domain is x, range is y. So the x-intercept, the graph intercepts the x right there at 0, 0, and it also intersects the y axis right there at 0, 0. So, and this graph is not symmetric, so that's why there's no symmetry right there. So the domain in range for the cube root, that's kind of easy. We'd like doing that. So it goes on forever on both ends. So from negative infinity to positive infinity, both for domain and range. The intercepts will be for x-intercept is at 0, 0, right there, because I see that. And the y-intercept also at 0, 0, because I see that right there. And the symmetry is about the origin, because it's a reflection right there. It's symmetric about the origin. So now we're going to go into transformations of functions. So now we need to match. We have 4 functions right there on top, and then we need to match the graphs. So the first graph is going to be the square root of x plus 2, because you can tell, I'm going to have to zoom in, because you can tell that the original graph would have been right there at 0, 0 and gone like this, like we did on the previous page. But notice that this graph was shifted 2 units to the left. So left, right there, that's the plus 2 that you see. Now the next one, the x minus 2, will match the following graph, this one right here, because the x minus 2 indicates the horizontal shift right there 2 units to the right, just like this one. And then this one, we have 2 transformations. One, that is the x plus 2 under the radical. So the square root of x plus 2 indicates 2 units shifted to the left, and also 2 units shifted down right there. So this one, from the origin, you can see that it went 2 units to the left and 2 units down. So that's why this is the function to represent this graph. Now the next one is kind of icky and funky. So that negative in the front, right there, that negative in the front represents a reflection across the x-axis. But this one, there's a typo. It should have been x minus 2 that represents 2 units to the right. I don't know if on your handout that has been fixed. If not, you need to fix that, because this one represents the last graph. So the negative in the front represents the reflection across the x-axis. That's why it looks like it's upside down, because that's the reflection across the x-axis. And the x minus 2 indicates that your graph was shifted 2 units to the right. And now here we have like a whole table containing all the transformations that could occur on any function. So the horizontal shift, it has to do with h right there, and it's always in parentheses. right there. So that's the horizontal shift. If it's plus h, that goes left. If it's minus h, goes to the right. Now the vertical shift, that's k, that's outside the parentheses or outside the root. Reflection could be across the y-axis or across the x-axis. It depends on where the negative is. If the negative is outside or in front of the function, that represents the reflection across the x-axis. But if the negative is inside or under the radical, in this case, that would indicate reflection across the y-axis. We have horizontal stretch or compression. Some books you will see as shrink, but it represents the same thing. Your handout should say BX and should say B right there. If it doesn't, please fix that. And it has to do, if B is greater than 1, then it's a horizontal shrink. If B is between 0 and 1, then it's a horizontal stretch. You won't see this very often. The vertical stretch or compression or shrink, you will see that more often than the horizontal. Now that's the number in front of the function or outside the radical. If a is greater, then it's a vertical stretch. But if a is between 0 and 1, that's a vertical shrink or compression. Again, the vertical stretch or compression will happen more often than the horizontal. You will see this more often than this one. Okay, so now we need to describe the transformation and then sketch the graph. And then state the domain and range and all the other good stuff. Now, this is the original function. From section 1, I know how to go back and forth between the rational exponent and the radical. So this and this are the same thing. So the function is actually square root of x. So the parent function would have been like this. So that goes through the origin, and it's just a square root of x. That's the parent function. Now this is the transformed. That's what I need to describe. Well, it went 3 units to the right, and it went 2 units up. So the minus 3 is telling me that it went 3 units to the right, and then the plus 2 is telling me it went 2 units up. So the starting point is right there, not vertex. The starting point will be right there at 3, 2. So that's where your starting point is compared to the 0, 0 from the parent function. And then you just start graphing there. Or you can make the table if you prefer. I would do that starting point 3, 2, and then go 1, 1, 1 up, 1 over, and then you follow the next point. So 1, 1, and then 2, 3, 4, and 2 up. And then you would go 2, 3, 4, and 2 up. That's where that point came from. The domain is very similar to what we just did on the front page. So it starts right here at 3, and it goes toward positive infinity. It's inclusive. And then the range starts right there at 2, because that's the y value right there, and it's going toward positive infinity. There's no x or y-intercept on that. Cube root, that's the parent function, and it looks like this. That's the cube root, and it was transformed into that. So we have a couple things that we're looking at. This negative in the front, that represents reflection across the x-axis. Notice how the minus is in front of the whole function. So that's reflection across the x-axis. Now this minus 1 represents the vertical shift. So it goes down 1. So instead of starting right there at 0, 0, it starts right there at 0, negative 1, because it went down 1. And it's also reflected across the x. So instead of looking like this, it's going to be a reflection across the x. So it looks like that. And again, you can always just make the table to graph that. The domain and range for the cube function, that's pretty simple, because it goes from negative infinity to positive infinity for both domain and range. The x-intercept is right there, negative 1, 0. And the y-intercept is right there at 0, negative 1. So x-intercept is right there. Y-intercept is right there. The next one, we have a bunch of things going on with this one. So again, I have the parent function right there, and we have a bunch of other things going on. So this minus in front, this negative, represents the reflection over the x-axis because that negative is outside the function. Now this 3 represents vertical stretch by 3. And there's that right there. Vertical stretch by 3. Stretch because it's 3 and 3 is greater than 1. Okay. And then we also have that +1 under the radical that represents horizontal shift. So it went left 1 unit. Best way I would do this one was just making a table. So when x is 0, go ahead and substitute 0 right there for x. So that's what I did. So then cube root of 1 is 1. -3 times 1 is -3. And then the next good number, and then you can try 1, 2, 3, and you're going to get all radicals and decimals, but we don't want to plot those numbers. Just go with whole numbers. So, and then 7 was another good one that I could plot. Substitute 7 right there for x. And I have cube root of 8, which is 2. -3 times 2 is -6. So I have 7 and -6 right there that I plotted. And then 0, -3, that's that one right there. And then I just plotted 2 more that I don't have on the table. Domain and range for the cube function, that's pretty simple. That's going from -infinity to +infinity for both of them. So the x-intercept is that point right there. So -1, 0. And y-intercept is this point right here, 0, -3. Now this next one, I crossed it out because that's really tricky. When you look at that negative right there, you're like, okay, is that a reflection? What do I do with it? So we're going to do a side note on this one. So you're not thinking that I just magically made that work. So what I would do for this one, it would be like I'm factoring out the negative out of this, and that will give you x plus 2 under the radical, and then the plus 2. That's where this -2 came from. So your starting point would be a -2 and then 2, including the reflection across the y-axis. So this negative represents the reflection across the y-axis. And then don't fall for it, because when you just look at this -2, you're like, right 2. But no, you have to go through the process, even if it's in your mind. You don't have to write it down, but just be careful because of the reflection across the y. Okay? So you go 2 left because it's the x plus 2 in reality right here. And then the plus 2, we knew that the outside would give you the up 2 right there. But add this to your notes. That's why it's a little tricky. That's why I was like, don't fall for it. Okay? So it's a reflection across the y. And then 2 left, 2 up. Notice that the domain this time, it goes from -infinity and it approaches -2, inclusive -2. Range is from 2 to +infinity. Well, it's going up right there. Okay? And it doesn't cross the y or the x-axis. And then I'll make another video for the end of page 3 and 4.